Okay, in this video we are picking up with our Unit 8 review on sequences and series, and we're going to be discussing how to find a specific term in a sequence when we've been given the value of the sum up to that term. So this is not really a tricky question as long as you understand what formula you're going to need to solve it, and the clue for that is right here in what's been given to you in the problem. It says the sum up to the 45th term is 4,500, and that means this is going to involve the sum formula for an arithmetic sequence. We have two sum formulas for an arithmetic sequence. We have the sum formula that says we have to multiply n by the first term and the last term added over 2. We also have the sum formula that says that we have to multiply n by 2a sub 1 plus n minus 1 times d over 2. And either one of these formulas can be used for different things, but what you should notice here is that we have this s sub 45, so we know it's one of these two s sub formulas, and they've given us the first term. They've also given us this. This is what we're looking for, a sub 45. So notice the number, the n value here is the same in each one. So s sub n, they're looking for a sub n. So because they gave us this piece of information and they're looking for this piece of information, this formula is much, much easier to use. So this is the one that we're going to be using. And remember, this is one of the formulas that's provided to you on the test for you to use. So they've given us the s sub n value. They've given us a number that this is equal to. So let's go ahead and figure out how we can plug things in. We know s of n equals this number. So I'm going to take this term and replace it with the number 4,500. Then on the other side of my equal sign, we need to plug in an n value. The n value that keeps popping up, s sub 45, a sub 45, that's the n value, 45. So 45 is going to be our n value. In our parentheses, we're going to need to take the first term and the last term and add them together. The first term has been given to me. It's right here. A sub 1 is 10, so I'm going to plug in the number 10. And the other term, a sub n, is the number I don't know and want to solve for. So a sub 45 is the one I'm trying to find. So now I've been given all of this information, and a sub n is the only thing that I don't know. So really, all we have to do in this, now that we know what formula to use, is just unwrap a sub n. It's pretty straightforward. So I'm going to start that by getting rid of this divided by 2 from my equation. I'm going to go ahead and multiply both sides by 2. I end up with 9,000 equals 45 times 10 plus a sub n. And now I can divide both sides by 45 to keep unwrapping this a sub n. And it looks like 200 is going to equal 10 plus a sub n. Now the only thing holding a sub n hostage is this plus 10, so I'll subtract 10 from both sides, and it looks like a sub n is going to equal 190. And remember, the n value that we've been using over and over is the number 45, so it looks like we found a sub 45. It's just the number 190. All we had to do was use the sum equation and kind of work backward. Not so bad. All right, let's go ahead and in this video, let's move on to a new thread. We're going to look at question 9 from the review, which is talking about diverging and converging, which is only for geometric series. So this is only geometric. So for geometric series, we're looking at adding together these different numbers and figuring out if they go toward a real number or if they go toward infinity. And we only have to find the sum to infinity if it converges at a real number. So let's go ahead and take a look at this first series right over here, 80 plus 20 plus 5. Let's see what the pattern is. So this is automatically geometric, which means I know I'm going to have an r value, so I don't even have to try adding and subtracting. We need to find the value that we multiply by here. So r is going to equal whatever we get when we take the number from our sequence and divide it by the one that came before. So 20 divided by 80, if I simplify that, I get 1/4. I already know it's a series, so I already know this pattern is going to repeat. I don't have to go checking any others. I found my r value. And because my r value is between -1 and 1, remember that's all we care about. Let's look at a number line down here. 0, here's -1, here's +1, and here are all our other numbers. Here's -2 and all our other numbers. The only window where we have converging is right here. Everything else diverges. So the number we just found, -1/4, is right here between -1 and 1, which means this is going to be converging. And because it converges, I have to find the sum to infinity. Now, the sum to infinity formula will also be given to you on the test. The sum to infinity is a sub 1 divided by, divided by 1 minus r. So in this formula, a sub 1 is the first term, 80. So the sum to infinity is 80 divided by 1 minus our r value, which was 1/4. All I have to do is plug that in the calculator. It'll tell me my sum to infinity, which is 320/3, or if you got a decimal, that's okay, 106.667. So part A is done. Let's go ahead and take a look at the pattern we can find in part B. We're going to start it the same way. We're going to look for r, and we're going to do that by taking a term and dividing it by the one that came before. So -10 divided by -2. The negatives cancel, we get the number 5. So r is the number 5, and because it's 5, that's way over here on our number line, so that's diverging. And because it diverges, we don't have to find the sum to infinity. We're done. All right. Let's go ahead and move on to question 10. We're going to take a look at the concert that's happening. The seats are arranged so that the first row has 30 seats, the second row has 35 seats, the third row has 40 seats, etc. And the pattern continues. We're going to find the following. So we're going to have to find how many seats are in the 18th row. So we're looking for how many seats are in the 18th row. So we're looking for ace of 18. So let's take a look at the information that's been given. The first row has 30 seats. The second row has 35. To get from 30 to 35, I have to add 5. And the same is going to happen again when I get from the third row. So to get from 35 to 40, I have to add 5 again. So it looks like we have an arithmetic sequence, and the D value is +5. So D is 5. I have the D value. I know how many are in the first row, and because it's arithmetic, remember the general formula for that, a sub n is dn plus a sub 0. So let's go ahead and create our equation based on the information we know. We're looking for ace of 18, which is going to equal the D value we found, 5, times the number 18 that we're trying to calculate, plus ace of 0. Ace of 0 is how many seats there would be in the 0th row. If we could go backward from the first row, follow the pattern in the opposite direction. So instead of adding 5 to move forward, if we subtract 5, there would be 25 seats in the 0 row. So we'll have to add 25 here at the end of our equation. So 5 times 18 plus 25 is going to give us how many seats there are in the 18th row, and there are 115. Now all we have to do to finish up our problem is figure out how many seats are in the first 18 rows altogether. And again, that's going to be a sum. We already know this is arithmetic. We know how many seats are in the first row. We know how many are in the last row. So to find our sum, let's use the formula where we have the first row and the last row in the equation. So let's go ahead and plug in the information we know. We're trying to find the sum up until the 18th row. That's going to equal our n value, which is the number 18. Our first number of seats in the row, which was 30, plus the number of seats we just found in the last row, which is 115, and then we take that and divide it by 2. If we plug that into our calculator, it looks like the sum of all the seats in the first 18 rows is 1,305 seats. We're going to pick up with the last 2 questions, or the last question in both parts, in the last video.